Hello everyone. Here we discuss how to apply nodal analysis in a circuit. Basically, the nodal analysis are used for defining currents or node voltages in a circuit. So first we see what is node. Basically, node is defined as a point where more than two branches meet together. So if you see this particular circuit, in this circuit there are three nodes. You can see a point where R1, R2 and R3 is meeting, that is our node 1, and a point where R2, R4 and current source is meeting, this is our node 2, and our base point is our node 3, where these four branches are meeting, that is voltage source R3, R4 and current source. These four branches are meeting with a point 3. So here we are we have three nodes. So this is the basic concept for node. So for applying nodal analysis we will follow some steps. So our first step is define node in a circuit. So we already define node in a circuit, and our second step is assume one node as reference node and assumes other nodes as some voltage values. So here we will assume node 3 as a reference node, that is 0 volt, and node 1 we will assume node voltage V1, and at node 2 we will assume node voltage V2. So now come to our third step. Our third step is assume branch current. So let's assume at node 1 we will assume our branch current is I1 for R1 branch, this is I2 and this is I3. So here we assume the branch currents, and for node 2 this is I2 is already defined, and this is I4 and this is I5. So if you see this circuit, all the branch currents are defined. Now come to the step 4. Step 4 is applying KCL at each node. So applying KCL, first apply KCL at node 1. I1 is incoming current and I2 and I3 are outgoing current. So I1 is equals to I2 plus I3. Now come to KCL at node 2. Here I2 is incoming current and I4 and I5s are outgoing current. So this is our KCL equation. Now write equations for each unknowns. So if you see, first we see the circuit. Here a current source I is given, so we can write I5 is equals to minus I according to current direction. And if you see the current I1, now let's see the equation for I1. I1 is defined as flowing from point 3 to point 1. So basically the potential difference for this branch current I1 is 0 minus V1. Initial voltage is 0 and final voltage is V1. 0 minus V1 प्लस सोर्स वोल्टेज अगर आप देखें, इफ़ यू सी द सोर्स वोल्टेज दैट इज प्लस वी ए अकॉर्डिंग टू करंट डायरेक्शन, that is VA divided by branch resistance R1. This is our I1, and if we see the value of I2, you can see I2 is V1 initial voltage minus V2 final voltage no other sources, and the branch resistance is R2, that is V1 minus V2 divided by R2. And now if you see the current I3, for current I3 is flowing from 1 to 3, initial voltage V1 minus node 3 voltage is 0, that is V1 minus 0 divided by resistance R3. Okay, now come to the I4. If you see the I4, for I4 initial I4 is flowing from point 2 to node 2 to node 3. Node 2 voltage is V2 minus 0, and the voltage source in this branch, there is one voltage source. If you see the value of voltage source according to current direction, that is minus VB divided by branch resistance R4. So these are the basic equations which we can put in the KCL equations and solve all these equations. So we will get the analysis for this circuit, and in the coming topics we will see the examples for nodal analysis. So please continue with me. Thank you. Please like and subscribe my channel.